Hello, in this tutorial we are going to learn how to chain multiple C++ link operators together to build a more complex expression tree. So basically in previous tutorials I've been showing how to use some very simple C++ link operators. Many of them could be implemented with simple for loops. Nonetheless, I've mentioned multiple times that the advantage of using them are when we can start chaining them together. Because if we did that with for loops, we would end having a lot of if-else conditions. And if we use C++link, for a person that understands this syntax, the expression tree is very simple, very compact, and we can clearly understand in each step what we are doing, how we are manipulating our sequence of elements, and our code becomes much more compact, much more elegant, and much simpler. So now we are going to start putting some operators together, and in this tutorial I'm going to show how to chain them to a very simple use case so we can understand this without complexifying much the program. But basically we are going to filter all the elements of an array to obtain all the even elements that are lesser than 100, and then from those we want to obtain the maximum value. So very simple, but it will illustrate how we can start chaining together and build more complex expression trees. So as target board I'm going to be using an ESP32 FireBeetle board from the FRobot, but basically, as I've mentioned multiple times, this is a generic C++ library. It can be used as a regular Arduino library to target other microcontrollers, such as the ESP8266. We can also use it outside the scope of the microcontroller programming, since this is a generic C++ library. It can be used in any C++ program. It's very powerful, very useful. So what we are learning here extends beyond the scope of the microcontroller programming. So, but moving on to the actual code, we start by including the C++ link library, and then we declare the using of the C++ link namespace like we have been doing before. Then, moving on to the Arduino setup, where we are going to rest the rest of our code, we start by opening a serial connection so we can output the results of our program, and then we are going to define an array of integers over which we are going to apply the filtering criteria mentioned before, and then obtaining the max value. Note that 98 is the value that fills our criteria, so it's lesser than 100, and it's the maximum even value from our array. Note that I have here the number 99 on purpose to illustrate that our filtering is working well, because this is the biggest number lesser than 100, but it's not even, it's an odd number, so this one is not the one we expect. 98 is actually the biggest even number lesser than 100. Obviously I also have here numbers bigger than 100, so they are also outside the final result. And then we are going to start applying our expression tree. But the first thing we need to do before doing that is converting our array to a range object, like we have been doing multiple times. We call this from array function, and we pass as input our array, and then we obtain a range representing the sequence of elements we had in our array and over which we are going to iterate. Then the first step we are going to do is obtaining all the elements of this range that are even. And for that effect, we are going to use the where operator, already covered in the previous video. And basically, this where operator allows us to specify a filtering criteria over a range, and it will return a new range with all the elements that fill that filtering criteria. And that filtering criteria is specified as a function. Here we are using the C++ Lambda syntax. Okay, so basically this is a syntax that allows us to define anonymous inline functions. It's very useful when we are using C++ link, because most of the functions that we use for example, for filtering, they are not reusable. We don't gain much in declaring them as named functions, and for readability is much easier if we have them inline here and we can read right away what they do. But basically we are going to cover in a minute the details of this syntax. But to finish the explanation, or to recall the explanation of how the where operator works, basically it receives this filtering function as input. This function will be applied by each element of our range. Okay, so it will be applied element by element, and for each element it needs to return a boolean. If it returns true, it means that element fills our filtering criteria and it will go to the final result. If it returns false, it means that that particular element doesn't fill our filtering criteria, so it won't be returned in the final result, in the final range. Now, looking a bit into the actual syntax of the Lambda functions, this corresponds to the captures of the function. It's a detail of the syntax that we are not going to use. Then here we are specifying the parameter of this function. Basically, it is an integer because, as I've said, this function will be applied by element of our range, and each element is an integer. And then we are going to specify the body. Basically, you don't need to specify the return type because it is inferred by the compiler, but we need to specify the body, and this body implements our filtering criteria. Basically, we want to check if an element that is passed to this function is even or not. The easiest way to check if an element is even, if an integer is even, is to check if the remainder by 2 is equal to 0. If so, it will return 2. True. If not, it will return false, and basically we have our filtering condition modeled here as a very simple function body. Okay, so basically this is it. After this operator, we should return a range on with all the even elements of our original array. After that, we want to chain another filtering criteria, okay? And the other filtering criteria is having all the elements that are lesser than 100. Let me tell you that if we wanted, we could have here a much more complex function, okay? The body of this function could implement both filterings, okay? It could check if the element is even and if it is lesser than 100. At the end of the day, that could be the filtering criteria for this function that we are using here. It could be the full filtering criteria for the where operator. Nonetheless, if we start putting in the same where operator a function that implements a lot of filtering, we start having a very hard to read function. It will start to have a lot of conditions to evaluate, and it starts to be harder to read. So typically, when you use this sort of libraries like cpplinq in C#, we typically prefer to chain together multiple where conditions, each condition multiple where operators, each operator implementing its own condition, than in the same where operator having a lot of conditions inside. So this is typically more readable and preferable, but obviously different people will have different opinions. Personally, I prefer to do this. One where operator has one condition. If I want other condition, I put other where operator below. And that's the approach we are going to follow here. So basically, to apply the other condition, to apply the second where operator, we need to keep chaining operators in our expression tree. For that effect, recall that this operator here returned the range, and then we just need to use here this operator to, over that range, apply a new cpplinq operator. So basically, this is it. Okay, this returns a range. This here says that over that range we want to apply a new cpplinq operator, and then here we apply the next cpplinq operator. It's again a where, okay? So very simple. As I was said before, I'm not going to explain this again. So basically it's another Lambda function. And in this case, our filtering condition is checking if this element is lesser than 100. If it is, this function returns true. If it is not, it returns false. And only the elements that are lesser than 100 will end up in the resulting range. So after applying these two where operators, we'll have a new range that will have all the elements that are even and that are lesser than 100. And then we can use another operator. Again, we use this operator here, and basically we call the max operator over the resulting range, and we will obtain at the end of this expression tree, if we check all the expression tree together, we will have all the elements that are even, that are lesser than 100, and from those we want the maximum one, the one with the maximum value, and as expected, like we have told before, it should be 98. And this is it. As output, we know that it is an integer because we are operating over an array of integers. We are going to store the value here in this variable called result, and we are going to print it to the serial port. So before we check the final result, let me just tell that this is a very simple use case, but we could apply here more expressions. We could chain here more expressions. If instead of having the maximum value, for example, we could apply an ordering operator, we could do a lot of stuff. Basically, we can use the multiple cpplinq operators as building blocks of our expression tree. And in a very elegant syntax, note that here we have 4 lines to implement everything, whereas if we had a for loop, we would have probably many more lines with if conditions, else conditions. It would be much more complex, but we could basically express our operation with 4 lines of code. And obviously for people that are not acquainted with this syntax, when they look for this for the first time, it is a bit complex. I felt the same when I started working with this kind of syntax, but after you get the hang of it, it's really trivial to understand what is going on here, and you'll see that it's much easier to understand an expression such as this rather than understanding what is when you look into a very complex for loop with a lot of if and else. It's much more complex to understand what's going on there. Here is just a bit of training, and you'll see that it will be much simpler, and your programs will be much more elegant and compact. But enough with the talk. Let's check the result, the final result. Okay, as you can see here, I've already uploaded the code to my ESP32. Let me just reset it again. Okay, so you can see the code running from the beginning, and as you can see, we have obtained here the value 98, like expected. The biggest even number that is lesser than 100 from our array. This is it, very simple. Obviously, the use case is not that complex. We could have much more complex use cases. We could be chaining operators over an array of objects. This library works wonders on those use cases as well. But naturally, I don't want to go right now to very complex use cases. I just wanted to check to illustrate a very basic example of chaining together the cpplinq operators to illustrate what we can do. My suggestion is for you to play around a bit with these for use cases that apply to your programs. Start trying to chain together operators, check the other tutorials and see the other operators we already have available and try to play a bit with them. You'll see that it's very interesting. That's it. Hope you have enjoyed this tutorial and thank you very much for watching.